Moving on to permissions. Needless to say, this is a very important topic because you want to know who has access to what resources on the system. You want to know who has access to what files, folders, and programs. Not only that, but when you're in the post-exploitation phase after you've compromised the host, one of the things you want to do is find files, directories, or programs with weak permissions that will allow you access to them, that will allow you to change them and execute them. Because these could be potentially used to inject quote-unquote malicious code into them. And I use quotes here because when we're doing an ethical hacking engagement, we're not actually injecting malicious code. We're injecting code that will sort of give us the upper hand or will allow us to escalate privileges. So we're just imitating what bad hackers would do. And here's what permissions look like. If you remember when we first learned about the ls command, I told you to look only at the very first column on the far left where we have the Ds and the dashes. And we said that D stands for directories. So here we can see videos, which is a directory. And the dash stands for files, like the root exec is a file and tom exec is a file. At that time, we ignored the rest of the characters. Now, however, we'll be looking at those. We'll be looking at what the RWX means. These are the permissions. So videos, for example, have the permissions of RWX, R-X, and R-X. What does all that mean? R stands for read. For files, that means you can see the content of the file. For directories, that means you're allowed to do a listing of the content of the directory. W, as you might have guessed it, means write. For a file, that means you can modify it. For a directory, that means you can create, move, or remove files in the directory itself. And X stands for execute. For a file, that means you can run the file as a program. Remember this one, it's important and it's going to come up later. For a file, X means you can change the program to an executable. For directories, it means that you are allowed to access the files in the directory. Permissions can be categorized. You've seen before the RWX, R-X, and R-X. These are categorized in threes. The first one was the user permissions or the owner permissions. So whoever created that file or directory, these were the permissions that belong to him or her. G are the permissions that are assigned to the group of the file or directory. And O are the permissions of everybody else. They're not the permissions of the owner or the group, but for everybody else on the system. And A are the permissions for everyone, all of those, U, G, and O. Now, if we want to change permissions, we can do that using three operations. We can either use the plus sign to add permissions, the minus sign to remove permissions, or the equal to specify that this is the only permission that I want. And we do that using the chmod command, which is short for change mode. It's used to grant permissions to other users, and it's particularly useful for making executables. The way this is used, we start with the command, the chmod command, then the category, either U, G, O, or A, then the operation, plus, minus, or equal, then the permission, read, write, or execute, and the file name that we want to change the permissions to. So for example, if I want to make a file executable for the owner, I would do chmod U plus X and the file name. If I want to make a file readable and writable by everybody, I would do chmod A plus RW, the file name. So in the last example, I'm saying change mode for all, add the read and write permissions to that file. And this is what we call world readable and writable files. World writable files, by the way, are a big security misconfiguration. We'll learn more about that in other advanced courses. Let's see a practical example of this. So as you can see here, I'm logged into three different shells. The first one, I'm root. And if I do a long listing, you'll see the different permissions on all the folders or directories under my home directory. The first one is the RWX. These are the permissions that belong to me as root. The second one, the R-X, is for the group. And the R-X, the last one, is for the others. Let me move on to the next shell. I'm logged in here as Tom, as you can tell from the prompt. And in Tom's directory, I have a text file called toms-file. Now, if you look to the right-hand side of the permissions, you'll see the name of the owner and the group assigned to the file. So Tom is the owner in this case, and cats is the group that's assigned to the file. So the first set of permissions, the RW, as we've said, these are the permissions for the owner. In this particular case, it's Tom. The next set of permissions, the R, this is the group's permission. And this is the permission that's assigned to the cats group. So anybody who belongs to the cats group will have read permission. The last one is the R for others. Anybody else on the system that is not Tom and does not belong to cats group will have read permissions. Let me change the content of the file. Right now it's empty, so I'm just gonna nano it and type Tom says meow. I'll save it. And I'm going to switch to the third shell where I'm logged in as Fluff. You'll see that I am in Tom's directory, /home/Tom. And if I cat Tom's file, I'm able to read its content. The reason being, Fluff is part of the cat group. And having the read permissions for the cat group automatically gives the permission to Fluff, meaning that Fluff can read Tom's file. Fluff, however, cannot write to Tom's file. I want to change that. I want as Tom to give write access to Fluff. I'm actually going to give it to the entire group. So I'm going to use the chmod command, group plus write Tom's file. So now everybody in the cats group will have write permissions to the file. Let me verify this by doing another long listing. And as you can see here, the second set of permissions have changed from read to read write. If I go back to Fluff and I do nano on the file and I'll add Fluff says meow 2, I'll save it. And it's saved. Brilliant. If I want to read it, I still can. Excellent. So now as Fluff, being part of the cats group, I was granted permission not only to read, but to read and write to the file. Let me see if I can actually delete the file. Oops, I cannot. I don't have access or permissions to delete the file. We'll get back to that in a second. Another post-exploitation tip, after you compromise a host, you want to find out what programs you can run as root. And you want to find out if these programs suffer from any vulnerabilities. Because if these programs have any security vulnerabilities and you're able to exploit those, you will be able to exploit them as root and you will get root privileges. If that doesn't work, you try to get access to other accounts and see what these accounts have permissions to. And see if they can run any programs as root. And then you repeat the steps. If they can, you look at these programs, you see if they have any vulnerabilities. If not, try to get access to more accounts and so on and so forth. These are all parts of the privilege escalation phase that we talk about in the advanced hacking courses. To do that, to see what kind of programs you can run as root, you do sudo -l. This lists the program that you can run as root. To run a program as root, let's say I want to run the cat command or the nmap command as root, you use sudo. So for example, sudo nmap will run the nmap program as root. You can set these privileges of who can run what as root in a file called the sudoers file, which is usually under the /etc/sudoers. In this particular scenario, I have root that can run all programs as root, obviously. And I've configured also Tom to be able to run all programs as root. However, for Jerry, I've configured only one program with the ability to run as root. So here, Jerry can only run the bin/cat command as root. Here's your mission for this section. If you've been following along with the exercise, remember how user Fluff failed to delete Tom's file? Find out what permission you need to change to allow Fluff to delete that file. Then I'd like you to create a file with the following text in it. Echo, open quote, you have successfully ran an executable file, exclamation and close quote. Using Nano, you can create this file and give the file executable permissions and then find a way to execute the file. In other words, run the file or execute it so you can see this line, you have successfully ran an executable file as output on your screen.